does make it so you can see the screen.
Yeah, I checked the broadcast and if you don't.
And then your screen size is bigger than the
Yeah,
screen.
so I'm going to fix that today.
Yeah.
It should be fine for the presentation, but I'll change it.
And there are more people today forking the repo. And so Noah must have the biggest battery of all computers here, because your screen's the brightest right now.
It'll last me about 2 hours probably.
So, did you find exports? It's the missing Linux utilities. Low battery. Do you have a charger for your phone?
Should be pretty.
20% battery left.
Whoa.
That's a.
Oh, close. Yeah. It'll survive.
Hmm?
I had 20 left. And it's on low power mode, so it should be fine.
Okay.
Okay, it is 3:30, so I'm going to get started. Today is part 2 of the Git. If you missed part 1, the slides will be up, and I'm also going to review some of the content very briefly today. So with that, I will get started. One thing I wanted to point out.
So is there anything new in the repo that people should pull out?
No.
Any changes?
Not yet. I was going to.
Okay.
After the talk, I'll commit my new slides, and then if you wanted to pull from the repo, then the updated slides will be there as a PDF.
Mm-hmm.
Okay, one thing I wanted to point out is I put a link at the beginning of the slides to something called Git SCM, which is where the open source Git is managed, and they have a lot more docs that go way more into depth than what I'm going to cover today and what I previously covered. So I'm going to start with a quick review. So this is basic setup of Git. Once again, we have your text editor, and then you're editing the current file, and it points to a version at in some computer at some Git version database. And once again, you can have a central repository, such as GitHub or Bitbucket, to host your Git repo. Another thing I pointed out yesterday about Git is the way it keeps track of file changes. It uses something called snapshots. So once again, if no changes are made to a file, it just keeps kind of a snapshot of the file and doesn't resave the full file again. This reduces the size of your Git repository. This is the general workflow I went over. You have your working directory where you're editing your current files. You add them to the staging area and then you commit that state to your repository, and you can check back out any one of those states to go back to a certain commit, and I'll go over that more today. Okay, so yesterday I also talked a little about Git in the command line. Just to review, here's initializing a Git project. You make your directory, you change directory into that new project directory, and you just simply say git init, and that creates your .git directory that we talked about last session. All right, something new I'm going to talk about when you first create your Git project. You may have files in your project that you don't want stored in the remote repository. This could be something such as like passwords or for your API or very sensitive information. And so to not store those files in your Git repository, you simply add a .gitignore file. And so what Git will do is go to this file and see, oh, what files do they not want saved? And I put a link to our URL. We'll visit it later. I found it very useful. It's a collection of Git ignores by developers that have been contributed via open source for most every type of project you wanted to do. So there's things for R, there's things for Python, etc. Another vital piece of a repository, especially if you're sharing it with multiple people, is what's called a README. And so you create a file called readme.md. The MD stands for Markdown. It's a version of markup. It'll be covered later in a later session. But basically, this holds information about your repository, such as who are the authors, a description, how to install anything that may need to be installed to run your project. Okay, one other thing we went over yesterday was viewing the status of your Git. So by simply saying Git status, we're given a text overview of what the current status of our project is. And to review, there are 3 places a file could be in. It could be staged, which if you do Git status will be in green. This is saying my file is ready to be committed. And to get it into the staged area, you just say git add and then your file name. The unstaged are files that have changes but are not currently staged. So that one's pretty obvious. And then there's a third one I don't think I mentioned yesterday, untracked files. So these are files that aren't even tracked by Git. So if they were deleted, you would have no previous version of them. And when you say Git status, there'll be a specific section that says untracked files, and then it'll list all your files. And you want to add those to your Git repository as soon as possible so that they are tracked in some way. Okay, so as I mentioned before, adding files, git add file name, or the dot, once again, represents everything in the current directory. So I want to add all the files that can be added in the current directory. Yesterday, one thing that may have confused you was using Vim to input my commit messages. So this is a much simpler way. So you just say git commit -m, and then in quotations put your commit message. This is a lot easier than having to go through Vim, which may be hard to navigate. So I wanted to take a moment to talk about commit messages because I think they're very important. They should be short but descriptive. And if you find yourself having too long of a commit message, it should probably go in the description. So down here I said git commit -m. The first string or the first M represents your message. The second -m is your description. So if you find, once again, if you find yourself with too long of a commit message, shorten the message and put it in the description. and that gets synced up with the commit. One other thing, this is just how I've always done commit messages. Capitalize the first letter of your commit message and no periods, but the description can literally be anything you want. You can make it as messy or as nice as you want. Okay, any questions thus far about anything I've covered? Feel free to interrupt me at any time if you have questions. I'd be happy to answer them.
And so if you go look on the Bitbucket page, you'd be able to see all of your commit messages along the far right side.
Yeah.
And you can literally understand what's been happening or what you've been doing or what your collaborators have. And you can go click on it and see the code at that point and even look at all the changes and stuff.
All right, the next thing I'm going to talk about are branches. And to explain this, I'm going to use this figure. It may look very strange at first, but we're going to break down what this represents and how it accurately represents Git branches. So first of all, time going across to the right. So this is a commit. So this would be like your first commit. This is a commit. This is a commit. Every dot represents a commit. Now each of these colored paths represents a branch. So this one right here represents master. So by default, when you run git init, you're on the master branch. Usually what the master branch should represent is a working version of your project, and we'll talk about that a little bit later. So the second one is another branch. You can have any name you want. I call it dev for development. I'll explain why I named it that later as well. And there's one part of this diagram I'd want to explain, and that is this right here. So that represents a new branch. So to create a new branch, you would simply use the git checkout command, but add a -e and then the branch name, and I'll go over that in the demo later. So basically, when this commit was made, someone decided to make a new branch.
Question.
Yes.
Where is origin?
So
what's the relationship between origin and master?
So origin, I'll get to later, but origin is where your remote repo is, and we're assuming this repo has no remote for now. So origin represents the place where your Bitbucket or GitHub repository is at. So you could have master be up here, this commit, and origin back here, and then you push origin all the way up, which we'll get to later, and then they sync together. But I'll cover that in more detail later. Any other questions thus far? Okay. All right, so here are our two branches. So here's a very important thing. Commits are isolated by branches. So any commit made in master doesn't affect anything in dev, and vice versa. Okay, so here is an example. It may seem like these commits line up at a point in time. Let's say this changes file A, and this also changes file A. The changes won't be, the changes in dev won't be present in master, and the changes in master won't be present in dev. Okay, so they are isolated by branches until you do something called a merge. And the merge is where you take that path and you bring it back into another branch. So what this does is it would take all the commits in here and try to merge them with all the commits of master. So you've made changes in one branch and you want to bring them into another branch. And this is done with the git merge command, which I'll cover.
So that is a picture there where you might actually be working on a set of scripts that let you analyze a certain type of data, and that would be the gray ones, and you share those with all the people in your group, and they use the same scripts to analyze their data. But you have an idea that you want to go and come up with a third way to analyze it, so you pull the development branch and try it out in blue, and you can work all by yourself, and you're not going to screw anyone up. They'll still be able to run all the same named scripts in the gray. And then once you know it's working well, you merge those new capabilities into the master branch, and all of a sudden everyone will have the new, fully tested out things. The same story would do if this was for a LaTeX manuscript, the master might be the person who's writing their thesis, and the blue might be me making a branch for editing on their thesis, and then they would choose to merge what's back.
Okay, so after our merge, if we looked at where the branches currently are, they would be at this commit, and your repo would say master and dev are both on this branch. If you were to check out and make changes to dev, dev would branch out again, and it wouldn't be synced with master. Okay, so here's the command I mentioned before. So you say git merge and the branch name. One very important thing to note is this merges the branch name into the branch you are currently in. So if I'm in master and I say git merge dev, that takes the changes in dev and puts them into master. Say I'm doing more and more development on dev, but I just want to merge, for some reason I want to merge master into dev, then I would check out dev, which we'll cover later, and then git merge master. So this is a very important note, that it merges whatever the branch name is into your current branch. Okay, so here's the git checkout command. So you can say git checkout a branch name, and that'll switch you to the branch with that name. You can also say git checkout in a commit hash, which is a specific commit. Once again, if you don't remember, this is what it looks like. There's also a shorter version that Git creates. It's an abbreviated version of the hash, so it's a lot shorter. It's only about this short, so you don't have to type out the full thing. Any questions thus far? So one thing I get asked a lot is like, why are we doing branches? A lot of people are very afraid of doing merging or having all these different branches with different code, and people are working in different places. How do they stay coordinated? So I actually think branches are important for two primary reasons. It separates your development from your working copy, right? You should always have a copy of your project that works, whether it be an R package that can properly compile and run as expected, or it's a version of your paper that has been edited to a certain point and doesn't have these comments that might be strewn throughout your paper, etc. The other thing is collaboration. As Roger mentioned, you can have someone working on their own branch. So someone could be doing the analytics branch of your project, and someone else could be working on the development branch of your project. And by segregating workflows, they don't have to keep track of what the other person has changed, right? Because all their changes are segregated into their own branch. I put a link in here. Bitbucket has some great documentation specifically on different types of workflow, and this is the link to the feature branch workflow, which basically says make each branch of your project a feature. So if you're going to add something significant to your project, make it a feature, so a feature branch, so a new branch, and the branch name is like, say I wanted to add disaggregation to my R package. I would say, all right, create a new disag branch, and I'm going to work on it and implement my disaggregation functions. Once it's finished and working as expected, I pull it back into master. Okay, so I'm just going to demo what all this looks like on the command line. And I'm going to make sure I'm in frame for this. Pull it over a little bit more. Okay. So, okay. So I'm in the path where I've been storing all of the projects for the TeaTimes, and I want to make a new Git project, and then I'll show you everything I covered in the slides. So I'm going to get my mouse in here, make directory, and the project name, so I'm just going to call it my project. Change directory, CD stands for change directory, into my project. So now you can see the path now points to my project. Once I'm inside my folder, I want to say git init, and it'll say, alright, I initialized your .git file in this current directory. So now I want to add some files to my project. So I created some. So I'm going to do actually this through copying them over. So I'm going to copy example files. And not copy. So CP stands for copy from, and then your toPath. So I want to copy this to the directory. So now, if I list all my current files, I see I have this new R file that's called date components. I'm just going to clear my screen real quick. And then you'll also notice I'm, of course, on branch master. That's the default branch. And I have the little plus. And so now if I want to see what that is all about, I can say git status. And it says, you're on branch master. You have these untracked files. So this is that third possible state for a file. So I definitely want to add that to my project so it's tracked. So I say git add, and then if I do git status, so changes to be committed, this is your staging area, right? I stage the file to be committed, so I can do git commit, and then -m and initial commit. So once again, -m, and then your commit message. Okay, so it says, here's some information about the commit. I changed one file. I inserted a bunch of stuff, which makes sense because I just added a file. And now if I do git status, it'll say on branch master, nothing to commit. Working directory is clean, which means there's no changes, nothing untracked, etc. Okay, so let's say I'm working along and I created a bunch of other scripts, and then I noticed this new script I added is not working as expected. So with this, pull that in. So what this script does is it's called extract date components. It takes in a string representing a date, and basically it splits it by a hyphen, creates a component list, and then returns the list. So it's not working as expected, and the reason why is actually, I'm saying, when I split the string by hyphens, I'm saying the first element in components is the day, second is the month, and year is the third. And for those familiar with date formatting, this is actually a reverse of what it would typically be. It typically goes year, month, day. So I'm going to go ahead and fix that really quickly by just reversing the indices. And I'm going to go ahead and save that file. So now, if I go back and I hit git status, oh, this is, I didn't open, that was the previous version. So, I'm just going to go ahead and quickly change it in here. Okay, so now I changed it using VI, which is just a text editor inside, but you can also just inside the command line, but of course you can use other text editors if you wish. So I'm going to go ahead and get status again. And now it says they're not staged for commit, but they're changed, right? So this has modified. And like I mentioned earlier, we can do git diff, which will show the difference in the changes in the previous version. So as I can review, I just changed those two indices. I look at it and I say, all right, that's good. I want to commit those changes. So git add, and then git commit, and then here's a message. So fix incorrect, or fixed reversed date indices. All right, and those files are committed. All right, so now what I'm going to do is I'm going to create a new branch. So the way to create a new branch is git checkout, and then you just need to put a -b for branch, for new branch. If I weren't to put the -b there, I could just put a branch name and it would try to check out that branch. So I'm going to create a new branch, and what it's going to do is automatically switch to the new branch I just created. So I've created dev, and now you can see I'm on branch dev. So let's go ahead and add some files in dev. So once again, I'm going to copy from my example files. Here's a simple text file. If I go git status, add that, and I have this new file ready to be committed. So I'm going to git commit, add sentence.txt. All right. So now I have made changes in dev, and say I want to go back to master. And one of the reasons I might want to go back to master is I realized I hadn't added a README to my master branch, and I really want that on my working copy of my code. So I'm going to go git checkout master, and I switch to my branch master. One thing you have to keep in mind is you can't have any unstaged changes when you try to check out a new branch. It'll say cannot check out branch, you have unstaged commits, please commit them. And if you save those changes to that branch, then you're free to move to any other branch you would like. So now I'm back in master, and I'd like to add a README, so I can copy over this README I created. Git status, and I'll say, all right, you have this new untracked file. For those curious what it looks like, here's what a simple README looks like. This is using Markdown, which just gets prettified when you open it in a web browser or other applications. So the pound makes that a giant big title. So I titled it Git Demo, and then an example of a project created for SDLE, and you can even include links, TeaTime, and then I put authors down there. So that's an example of an extremely simple README. So I'm going to go git add everything. So the screen, git status, new file. So I'm going to git commit add README. And READMEs are very conventional for all projects, so if you go and visit other repositories on Bitbucket or GitHub, you will definitely see a README in the project as something that you can read to understand what the project is about. Okay, so now let's think about what just happened. So I started in master, I added the R script, committed those changes, I made a new branch dev, went to that branch dev, and added a file. Then I went back to master and added another file. So the text file I added in dev is not in master. If I list the files, I only have the README and the R. Whereas if I would go git checkout dev, and then list the files, you notice instead of the README, I have the sentence.txt file. But now, say I'm doing a bunch of development, and now I think it's I'm ready to pull in sentence.txt into my master branch. So what I'm going to do is I'm going to go to my master branch, so go back, and then now I'm going to perform a merge. So if you remember, if you run git merge, so it goes git merge and then the branch name, it will merge this branch into the current branch. So what this is going to do is it's going to merge dev into master. And so what's awesome about Git is that it will try to resolve the merge all by itself without you having to do anything. It'll notice, hey, that sentence.txt is in dev, but it's not in master, so I know I need to pull that over. So if I run git merge, it'll open VI. All you have to do is press Shift ZZ, and it automatically creates the commit message for you. It was like merge branch dev was the commit message. So now you can see it merged by the recursive strategy, which you don't have to worry about, but there's multiple different methods for merging. And then you can see it added sentence.txt, one file change, and one insertion. So now if I clear and I look at all my files, you notice now I have the readme, daycomponents.r, and sentence.txt. Okay. So what I'm going to do next is go over a little. Yes.
So what if you also made changes to the R file and dev? And what's going to happen in the merge?
It's going to resolve those for you. It's going to trump the changes in master with the ones in dev. And if for some reason you changed it in both places and it can't resolve the merge, what it's going to do is it's going to say you need to resolve this file, and it'll give you the name of the file before merging. So you're going to have to actually go in there, and there's going to be some text markup in there where it says, here's where the problem happened, fix these certain lines of code, you fix them up, and then you commit the changes, and then you're all good. But that's a special case, and there's plenty of documentation on the links provided on if there's a conflict, how to resolve merge conflicts.
And you can also use graphical merge tools. So you can define in your Git repo a graphical diffing tool and a graphical merging tool. One we use typically is meld, and it will throw both the file in both branches left and right and highlight by color how they're different. And then you can literally go through and say, I like this one here, I like that one there.
As I mentioned briefly, remote repositories. So these include primarily Bitbucket and GitHub. There's also GitLab and a couple others nowadays. So there's only a few commands you need to know to get your Git repository up in the cloud. So this first one is you just say git remote add and then the repo URL. And so this will be provided by Bitbucket or GitHub. And that will just basically say, this is where I want to store my Git repository. So git push origin pushes everything up to the cloud. Remember, origin represents the pointer to your cloud repository. So I'm pushing it up to the cloud. And then say someone made changes, push them to the cloud, and then someone else on your team wants to get them. You just say git pull origin, and then those changes will be brought down. Now there's variations of git push and git pull. You can also add branch names to them. So if you only want to push a certain branch to the cloud so that it doesn't get overly crowded with a bunch of branches that may no longer be used and only on your machine. And then you can also do the same with git pull. Okay. So I'm going to show you a little bit of Bitbucket, which I think is good to know how to navigate and create a repository. So I logged in. create repository. Okay, so I'm the owner of the repository, and I'm just going to call this TeaTime. Okay, so you can choose to make it private or public. If you make it public, anyone can access it. And then we want it, of course, to be a Git repository. So I'm going to go ahead and create the repository. And as you can see, the repository was created. And then, can I get the URL? Okay. So you want to go, so if you're starting from scratch, you can follow these commands. Or if you already have an existing project, which is what I have, you can go down to this tab, and it basically gives you some instructions. So here's the one I was talking about. Go back here, paste that. So what it does is git remote add origin, and then the path to your Git repository. So I'm going to do that, and now it's added. So now if I just go git push origin, for this I'll just do master. So I'm only going to push up master. And so now it just gives you some status updates. If something went wrong, it would print out an error message, but we see, all right, we have a new branch, master. So if I go here and refresh the page, I should have some code, and I do. So let me pull that over, sorry. Okay, so as you can see, it's an overview. One nice thing about these Git repository services is it pulls your README in automatically and renders it. So this is that README that I created, right? And it interprets it. I formatted my link incorrectly, so that's why it showed up like that. But links would just show up as like SDLE highlighted in blue. All right, so some ways to navigate Bitbucket. Over here are a bunch of options. So I can go over here to source. Flag rate. If it puts even about using the command line.
So the standard problem that people run into is that you're using Git and you have a copy up in, say, Bitbucket, and then something gets screwed up on your local machine and you can't successfully push or pull and gives you all these complaints and you have no idea what's going on. And the solution to that is to just copy the folder where all your code is to somewhere else on your computer as a backup, just as a stash it somewhere. Then delete the Git folder, the code folder that you were working in, reclone from Bitbucket, and then move one file in that you want to keep or two files in that you want to keep. And then you should be able to push back and it'll be okay. So I always think that the one up in the cloud at origin is the master copy that you have. And branches, usually it's best to just try and live in the master branch at the beginning as you just get used to things, just get used to this pattern of pulling and pushing and commit messages. But then once you get going with branches, it works out really nicely.
Yeah, if you're working by yourself in the beginning, it's actually better to just stay on master to simplify and increase development speed. Good.
Cool.